Ever wonder how machines can tell the difference between a cat and a dog, or a chair and a table? This amazing feat is possible thanks to the marvels of machine learning, a cornerstone of our technology-driven world. The key lies in the concept of contrastive learning. Intrigued? Let's delve deeper. So, what is contrastive learning? It's not as complex as it sounds. Imagine you're in a room full of objects. Some are similar, like a group of red apples, while others are distinctly different, like a blue ball sitting apart from the apples. Now, if you were asked to identify the odd one out, you'd probably point at the blue ball, right? That's because, as humans, we naturally understand contrasts. We can easily spot differences in colors, shapes, sizes, and so forth. The same principle applies to contrastive learning, which is all about teaching machines to recognize such differences. In the world of machine learning, contrastive learning is a method that involves distinguishing between similar and dissimilar things. It's like teaching a toddler to recognize that a cat is not the same as a dog, even though they're both animals. This method involves presenting the machine with pairs of examples, where one is similar to the original object or concept and the other is different. Let's consider a practical example. Suppose we're trying to teach a machine to recognize images of cats. We would present it with pairs of images. In each pair, one image would be a cat and the other could be anything else, a dog, a tree, a car. The machine's task is to learn that the cat images are similar to each other and different from everything else. The goal of contrastive learning, therefore, is to create a model that can correctly identify the similarities and differences between objects or concepts. It's about training the machine to understand that while two objects may share certain characteristics, they can still be different. But why do we need to teach machines to understand contrasts? Well, it's because understanding contrasts is fundamental to learning. Whether we're learning a new language, a musical instrument, or recognizing objects, we learn by distinguishing the new from the known, the same from the different. In essence, contrastive learning is the process of teaching a machine to understand contrasts. But how does contrastive learning work? What's under the hood? To understand it, let's start with the basics. Contrastive learning revolves around the concept of positive and negative pairs. Imagine you're trying to identify a specific type of bird. A positive pair would be two images of the same bird species, while a negative pair would be an image of the bird species you're trying to identify and an image of a different bird species. In the world of machine learning, the system is given a positive pair and a set of negative pairs. The goal is to make the system learn that the positive pair is more similar to each other than to the negative pairs. It's a bit like playing a game of spot the difference, but instead of finding differences, the system is learning to recognize similarities and contrasts. Now let's talk about loss functions. These are kind of like the scoring system in our spot the difference game. They measure how well the system is doing at recognizing the contrasts. If the system correctly identifies the positive pair as being more similar to each other than to the negative pairs, the loss function score is low. If it gets it wrong, the score is high. The aim is to minimize this loss function score, which in turn improves the machine's ability to recognize and differentiate between the positive and negative pairs. This process is done iteratively, with the system learning and improving with each round. Over time, the system gets better and better at recognizing the contrasts. It learns to identify the specific bird species in our example, distinguishing it from other species. And it's not just about birds. This mechanism can be applied to a wide array of tasks, from recognizing faces to identifying diseases in medical scans. The beauty of contrastive learning is its simplicity. By focusing on recognizing contrasts, machines can learn complex patterns and relationships, all while minimizing the loss function score. And that, in a nutshell, is how machines learn to recognize contrasts. Why does contrastive learning matter? What's its significance in machine learning? Well, contrastive learning is like the secret sauce that powers some of the most innovative applications in the field of artificial intelligence. It's a tool that's as versatile as it is powerful, and it's worth getting to know. Let's start with image recognition. Without contrastive learning, our ability to automatically categorize and identify images would be severely limited. You see, contrastive learning allows an AI to discern between similar and dissimilar images by comparing them. This is how your smartphone can identify your face among thousands of others, or how a self-driving car can distinguish between a pedestrian and a lamppost. But it's not just about images. Contrastive learning is also a game changer in the world of natural language processing. Ever wonder how chatbots can understand the context of your messages? Or how search engines can deliver relevant results based on a few keywords? Contrastive learning plays a big role here. By comparing different sentences and their context, the AI can develop a deeper understanding of language and deliver more accurate responses. And let's not forget about voice recognition. Your smart speakers, your virtual assistants, they all rely on contrastive learning. It allows these devices to understand not just the words you're saying, but the nuances of your speech, the accent, the tone, everything. So you see, contrastive learning is everywhere. It's in the apps we use, the devices we interact with, and even in the technologies that are yet to come. It's not just a fancy term in a data scientist's toolbox. It's a critical piece of the puzzle that makes machine learning, well, learn. And as machine learning continues to advance, the role of contrastive learning will only become more important. It's the key to making our interactions with AI more seamless, more intuitive, and ultimately more human. As you can see, contrastive learning is a critical component of many applications we use every day. Contrastive learning isn't without its challenges. What are they? Well, let's dive right into the deep end. One of the primary challenges in contrastive learning is the difficulty in selecting negative samples. Negative samples are essential in contrastive learning because they provide the contrast that allows the model to differentiate between similar and dissimilar data points. However, choosing these negative samples is no walk in the park. The challenge here lies in striking the balance between choosing negative samples that are too similar or too different from the positive sample. If they are too similar, the model may struggle to distinguish the positive from the negative, leading to poor performance. On the other hand, if the negative samples are too different, the model might not learn anything meaningful from the contrast. Another challenge is the risk of overfitting. Overfitting happens when a model learns the training data too well and can't generalize to unseen data. In the context of contrastive learning, overfitting can occur when the model focuses too much on the contrasting pairs in the training data and fails to generalize to new contrasting pairs in the test data. This can lead to a model that performs well on the training data but poorly on the test data, which is not what we want. These challenges, among others, make contrastive learning a complex and intricate field. But it's important to remember that these challenges aren't insurmountable. They are merely obstacles to be overcome as we continue to refine and improve contrastive learning techniques. The beauty of contrastive learning, and indeed machine learning as a whole, lies in its iterative nature. Each challenge we face is an opportunity for learning and improvement. As we grapple with these challenges, we gain a deeper understanding of the underlying principles and develop more robust and effective models. While not without its hurdles, the potential of contrastive learning is vast, and that's what makes it such an exciting field to be a part of. So, what's next for contrastive learning? What does the future hold? The fascinating journey of contrastive learning is far from over. In fact, it's just beginning. The potential for this approach is vast, and the horizon of possibilities is expanding every day. On the frontier of this exciting field, researchers are tirelessly working to push the envelope, exploring new ways to make machines learn more efficiently and effectively. One of the promising areas of focus is the enhancement of unsupervised learning. As we move forward, we can expect to see contrastive learning methods that can learn even more from unlabeled data, reducing the need for expensive and time-consuming data labeling processes. Moreover, these advancements could lead to the development of more robust and versatile AI models, capable of understanding and interacting with the world in ways we can only imagine. Another exciting avenue is the integration of contrastive learning with other learning paradigms, like reinforcement learning or generative models. This cross-pollination could lead to the creation of hybrid learning systems that can leverage the strengths of different approaches. Such systems could solve complex tasks that require a deep understanding of the relationships between objects and concepts, opening new doors in areas like autonomous driving, personal assistant technology, and more. Lastly, we anticipate an increase in the use of contrastive learning in real-world applications. As the technology matures and becomes more accessible, industries from healthcare to finance could benefit from the unique capabilities of contrastive learning, transforming the way we live and work. As we continue to push the boundaries of what machines can learn, contrastive learning will undoubtedly play a crucial role. In summary, contrastive learning is a fascinating area of machine learning. We've delved into its mechanics, significance, and challenges, and glimpsed its exciting future. As we continue to explore the potential of contrastive learning, who knows what we'll be able to teach machines next?